Slopes of perpendicular lines. In a plane, two lines are perpendicular if and only if the product of their slopes is -1. Let m1 be the slope of L1 and m2 be the slope of L2. L1 is perpendicular to L2 if and only if the following statements are true. m1 times m2 equals -1, m1 equals -1 divided by m2, m2 equals -1 divided by m1. All are mathematically equivalent provided the slopes are non-zero numbers. Another way of stating this idea is to say that the slopes of perpendicular lines are negative reciprocals. This will be useful in cases when you need to prove lines perpendicular, including proving that certain triangles are right triangles. First, let's prove the theorem. Given L1 is parallel to L3 and L2 is parallel to L4, to prove the theorem, we can focus our attention on lines that pass through the origin. Because parallel lines have equal slopes, proving L1 is perpendicular to L2 is enough to prove that L3 is perpendicular to L4. So let's prove L1 is perpendicular to L2 by demonstrating the product of their slopes equals -1. Now, let's zoom in and focus on the lines between x equals 0 and x equals 1, so from 0 to 1. At x equals 1, the y-coordinates of L1 and L2 are given by m1 and m2, as shown. This makes sense as the slope is the change in y over the change in x. As x goes from 0 to 1, the change in x equals 1. Therefore, the y values for L1 and L2 are m1 and m2. m1 equals the change in y1 over the change in x1, which equals the change in y1 over 1, since the change in x equals 1, equals the change in y1. Therefore, m2 equals the change in y2. Let's now use the Pythagorean Theorem, c squared equals a squared plus b squared, to insist on a right angle at the origin. Side C is the hypotenuse and the distance between the points along the vertical line x equals 1. It has length m1 minus m2. Next, use the distance formula to find the length of each leg. The lengths of legs A and B can be found using the distance formula, which is d squared equals x2 minus x1 squared plus y2 minus y1 squared. So if you plug in numbers here, we get that a squared equals 1 plus m1 squared and b squared equals 1 plus m2 squared. And we get c squared by squaring our result for c from the prior slide. So we get c squared equals m1 minus m2 squared, which is m1 squared minus 2 times m1 times m2 plus m2 squared. So from the previous slide, we have that a squared equals 1 plus m1 squared and b squared equals 1 plus m2 squared, and c squared equals this whole thing here, m1 squared minus 2 m1 m2 plus m2 squared. So we have a squared plus b squared equals c squared, so we plug all this in here, we simplify, and we get m1 times m2 equals -1. Therefore, m1 m2 equals -1. Therefore, m1 equals -1 over m2, and m2 equals -1 over m1. In a plane, two lines are perpendicular if and only if the product of their slopes is -1.